Good morning, everyone, or good afternoon, or evening, for those attendees from the Middle and Far East. Thank you all for tuning in this webinar of VONK on prefabricated buildings. My name is Dave Oesterold. I work for VONK as a business development and sales manager, and I'm very happy to welcome already quite a lot of attendees today. I see it's still climbing, more than 50, and more than 140 have registered. So I think we'll have at least an audience of around 100 people. In the next half hour, I will inform you about the use of prefabricated buildings and how these can be to benefit of your business. After my presentation, I will be pleased to take any questions you might have. You can actually type your questions in the right chat box at the right of your screen. You can do this already during the presentations. My colleagues will collect the questions and I will deal with them one by one after my presentation. During my presentation, I will follow the following subjects on the agenda. After having introduced VONK shortly, what is actually the prefabricated building? What do we mean by that? Why would you choose for a prefabricated building? Where can you use it for? And where can you place it? Engineering and design aspects, very important. Different types of construction and also areas of attentions. Logistics, very important as well. And I'll also show you some use cases and finish with a recap. First, let me introduce shortly to you who VONK is. We are a solution provider for all kinds of challenges regarding power conversion, electrical and instrumentation, and control and automation. We do this in 6 main markets: the traditional oil and gas market, the green hydrogen production market, industry in general, uranium enrichment, defense, and scientific research. And in these markets, we focus really on the energy transition. So we're very active in delivering power supplies for green hydrogen production for the large-scale electrolysis. We help also reduce the energy used in different industries like the uranium enrichment. And we also help to decarbonize the traditional industries like oil and gas. An example you actually see behind me and also in the right picture on the screen. We have different services and different products built up in more than 87 years meanwhile. Next to the prefabricated buildings, we have solutions for control and automation, especially rejuvenation of existing plants. We have power management systems that we actually use in different kind of solutions we have. We also have different drive solutions, for example, for the MF drive systems to power the machines for uranium enrichments, the centrifuges. We deliver all kinds of industrial grid connections. And last but not least, we design and build special power converters for the science research industry, but also for green hydrogen production, the power supplies. So to start with, what is actually a prefabricated building? What do we mean by that? We can see it as a relocatable housing of different kinds of equipment. And the equipment can be power distribution equipment in electrical substations and e-houses, automation systems, IT/OT and telecom, instrumentation, energy storage systems, power generation, harmonic filters, or power supplies for the large-scale electrolysis. Also in the building, we incorporate all kinds of auxiliary equipment for the climate control in the building, for the lighting, for fire and gas detection, etc. These buildings are fully functional tested in the workshop before they are delivered to site as a complete integrated product. So you can actually say that it's a fully plug-and-play solution. And in most cases, it's a containerized solution. Why would you then choose for a prefabricated building? And in this case, instead of building up a building at site. First of all, and it's the main reason overall, is reduction of the overall cost. And it's due to different causes. First one is you see quite often that the access to the site is difficult, can be difficult, or time limited, that you only have certain periods in the year that you can access site. and then you want it to be there as shortly as possible, and that can be done with a prefabricated building. It takes much longer to build it on site, like you see in the picture on the right, and you also need a lot bigger plot space. You need much more personnel when you build it on site. So for a prefabricated building, much less personnel. The installation time is reduced drastically. There's also a large reduction of civil works at site, and you do not have to transport cement or water or all kinds of other materials to site. This is just one prefabricated building and connect it, and you can start your business. And also very important, there's much less exposure to safety and health risks. Also, it's delivered as a fully tested and integrated product. So all the testing, including the pre-commissioning, is done in the workshop, can be witnessed by the suppliers, the OEM suppliers, but also by you, the end client. All the interconnecting cables, they stay in place when it's transported to site. There's no retesting needed at site. And this especially when you have sensitive equipment, that is often the case with electrical instrumentation and control equipment, that you can do this in a fully controlled workshop environment. So I said it before, but I will repeat it probably a couple of times more during this presentation. It is really a plug-and-play solution. Also, from a contractual point of view, it is, has a lot of benefits to choose for a prefabricated building. You have one single point of responsibility, and so that means that you do not have to reduce your, you coordinate yourself all the contracting parties involved. Because you have much less materials, actually only the prefabricated building, you have no warehouse management at the site either. You can reuse your buildings, relocate it easily, and also very important, it's fully recyclable. So what can you use prefabricated buildings for? Well, there's actually many applications, and I've made a selection here on this slide. It is used a lot for electrical substations and e-houses. Also for power generation, we have delivered them with gensets inside. Battery energy storage systems you see coming up more and more. They can house also auxiliary and instrumentation. So in the FAR buildings, they call them field auxiliary rooms and instrumentation rooms. Control rooms, of course, but also coming up now the business of green hydrogen production, where you can have an electrolyzer and or the power supply within the containerized solution. There are a lot of configurations possible when you look at prefabricated buildings. I have made some distinctions here in a different kind of configurations. When we look at floors and rooms, you have, which is most common, the single floor solution. It can be elevated, but the building has one single floor. But you can also have stackable units or multi-floor buildings. And that also, we have delivered quite a lot of those in the past as well. And within the room, you can have different rooms. You can have either one big room, or you have, what is often the case, separate rooms. For example, when you want to separate batteries from the rest of the building. When you look at sizing, as actually, well, there are limits, of course, but you can actually build them as big as you need them for your application. You see in the picture on the left is quite a wide and long building. That is, well, we can build it in the size that you need it. You can also convert standard-sized ISO high cube containers, for example, 20 foot, 40 foot. You can convert them in a solution applicable to your situation. Where can you then use a prefabricated building? It's actually anywhere you like, because it is easily transportable and relocatable. You can put them at any site you actually like, and especially those sites where it is hard to build a building, to erect a building in an in situ situation. So, for example, harsh environments or limited access. Then it is especially for those location is a particularly good selection to go for prefabricated buildings, like you see in the pictures here in the desert or even offshore. Also very important in the design and engineering phase, what you should take into account. In this presentation, I will go into detail in these following design and engineering aspects: the painting, coating, the climate control inside the building, the different fire rating classes, fire protection and detection, the cabling inside the building, the plot space, the footprint versus the required sizing. When you are having a hazardous area or an ATEX situation, and also when you are in a situation where you could have an explosion regarding blast resistance of the buildings. First, have a look at the painting coating. There are different ways, of course, to coat your to protect your prefabricated building against the environment. And depending on the sort of environment and also the lifetime that you are foreseeing, you will have to adapt the coating to that situation. It's the same picture on the left as in my background is an example of a hybrid power system, decarbonizing gas production offshore. You will, as you can imagine, have quite harsh conditions there with the salt and the wind, etc. In the desert, temperatures, they go up very high and very low at night, and also the rainforest environment where there's a lot of rain and moist, of course. So, depending on the situation, you adapt the coating. Climate control in the building, also very important. You have all kinds of equipment in the building that needs to be protected, often cooled in hot climates, or also heated in when it's a lot colder. And there are different ways to do this. Natural ventilation is the easiest way with louvres. Then you have more the forced cooling and heating is with packaged units in the picture in the middle. Packaged HVAC units, heating, ventilation, air conditioning, or a split type. And when would you choose for one of those two? It's also depending, of course, on the heat dissipation coming off your equipment, but also when you need humidity control or fresh air intake, fresh air replacement, then you would go for a package unit earlier than a split type. Fire rating, also very important. This is quite a full slide, but I'll try to explain it. That is it's very important, depending also on your company's philosophy, how you deal with fire detection and protection of your building. And then it's very important where is the building located, nearby which kind of installations and equipment, and their accompanying risks, which escape routes are there to safe havens and muster points. If it is onshore, you have a certain ISO standard. If it is offshore, you have another standard you have to meet the requirements of. And also depending on the sorts of fires, when the material is mainly on a cellulosic basis in your building or on a hydrocarbon basis, you have different fire ratings. And these fire ratings, they are often indicated as a letter and a number. And the letter shows you, for example, if it's a 30 fire rating, it indicates a requirement that it has a 30-minute resistance, thermal resistance, and a 60-minute structural integrity resistance against the cellulosic fire. Well, you want to be alarmed in a very early stage when there would be a fire. Then there are all kinds of detection systems, smoke detectors, but also the more sophisticated systems like FESTA, the very early smoke detection and alarm systems. And then you would like to be alarmed. That can be via a horn, an audible horn signal, or in the middle you see a system that's connected to your control, your plant control system that gives you the alarm in the case there would be a fire. And then there are also ways to extinguish your fire, and it can be with handheld devices. Also, they are almost always there, but also automatic extinguishing systems, like in this case, in this picture, you see a NOVIC system where you have pressurized inert gases to extinguish your fire, in the case there is one. The cabling between the equipment inside the building, very important, of course. They can either be installed along the ceiling or in the raised floor. Yeah. And depending on the option that you choose for, you always have to take into account what will that do to the overall height of your building. Yeah, that is an important factor. And good to know is that once the cables are installed inside the building and also tested, they will remain like it is. So from the workshop to the worksite, that will not change. The cabling will be as is installed already in the workshop environment. Depending on the size and also the transportation limits to site, between the workshop and the site, you might need to have the building split in what we call shipping sections. But it's easily done. We will do that, of course, in the design phase already. And you can see in the two pictures on the left from the outside and the inside of the building. So a separate shipping sections will then be transported from workshop over sea or over road to your site, and then will be actually connected together and quite easily connected. And it can be commissioned, and then your operation can start. Or you have single shipping units, as you see in the picture at your right. Often in the case of chemical or oil and gas plants, you can have hazardous areas. You can have different kinds of combustible or toxic gases escaping from other installations. And you want to protect your prefabricated building against it, of course. So then you will have separate and special airlock entry combined with access control. You see that as the little steps in the yellow building, where you see the door. There's actually a kind of separate part at the side of the building. You want to create overpressure in your building, so the gas from the outside cannot enter your building. And this special gas detection, of course, inside, and using also air ventilation and shut-off dampers. And you want to take your fresh air in from a safe zone. So they could sometimes be quite a distance away from your building. Then you also have sites where you can have explosions. There's a risk of explosion. And when there is a higher risk, you always have to make a quantitative risk assessment that determines where the explosion and then the blast as a consequence of the explosion is coming from, the direction, what the peak value is of such a wave, and how long it takes. And resulting, you will have different levels of blast resistance of your building. And that can have impact on the special doors to be designed and installed, as you see in the picture. Other additional reinforcements, or the thickness of your steel, or even the corrugation depth of the walls of your building. And that brings me to actually an overview in the form of a table between the different construction types of prefabricated buildings and the versus the features and the areas of attention. I've tried to summarize this in a table. Of course, it's a qualitative risk comparison of a comparison between the different buildings. You see in this table where I've compared the concrete prefabricated buildings with fully welded steel buildings, and then the modified standard shipping containers. And you also have a system we also built, and you saw that in the startup slide, for example, skid-framed buildings with sandwich panels. Well, the first two, the concrete and fully welded, they are actually mechanically the strongest, followed by the standard shipping container, and the sandwich panel buildings are somewhat less strong. But it's also depending on the situation and whether it needs that strength or not, which option you can choose for. And you have differences. Weight, of course, you can imagine concrete is very heavy. You have to take that into account when you want to transport that to site. Fully welded, it is a lot less, it's much lighter, and the sandwich panel buildings are the lightest. Air and water tightness, quite comparable with each other. I would say the fully welded option is best as the best tightness against air and water ingress. Ambient conditions, I would say fully welded again comes out the best with sandwich panel buildings. Fire resistance, well, more or less the same. And and generally spoken, also depending on how you protect your building with coatings and stuff, the concrete and fully welded buildings last longest. And maintenance-wise, also these two can be best maintained and the standard shipping containers. Logistics, very important. Once you have built your plug-and-play prefabricated building and tested it, you want to transport it to site, and it can sometimes be quite far away from where you have built it. And that can be done in different ways, over the water, over the ocean, but also let's see over a kind of a river or a lake. And sometimes you need very special equipment when you have quite large buildings, you can see in the picture on the right. Also important to take into account is the customs clearing and import-export, all the paperwork around that. And don't forget, you also have, most of the times, have to transport also loose equipment, like external HVAC units that then will be placed on the container again at site, or stairs and railway systems on the outside, those kind of things. You need to lift your buildings as well. There are different ways to do that. As you can see in these pictures, you have the sling sets with single point lifting or with spreader bars, depending, of course, on how heavy your building, including all the equipment inside, is. Which brings me to the use cases. Use cases are always good to see what can you actually do with such buildings. I have selected a couple of examples. We have built hundreds of those buildings, but some interesting cases to show and to share with you. On the next slide, this is one in Qatar, an electrical substation, 11 meters long, 4.5 wide, and 4.35 meters high for 450 volts. So this is low voltage switchgear, and it's actually used as for power distribution on an offshore platform. They have quite large HVAC units on the top, a SIL2 rated HVAC control panel inside, and an active gas system. Pictures say a lot more than words, although this is quite a full picture, but to give you an idea of during the design phase, you need to know where your equipment needs to be placed within the building, taking into account the size of the different equipment, of course, and also the escape routes between the equipment and where you place the doors. So you see a double leaf door at the right here and a single one at the left. That in another overview is an architecture layout, also from the top. From the side, it looks like this. You see some monkey stairs at your left, some railing, and you see the HVAC units on the roof in this case. And if you have a view from the roof, you can, or from the top, you can onto the roof. You can also see the HVAC units and the different ducts that lead the cooled air into the building. Inside, during work in progress, you see also this building has quite a lot of insulation inside. And when you also model it in a 3D version, you will see you can actually design your complete building in a 3D model, turn it around, see how everything is actually located compared to each other, all the different components and different systems. And it's a nice picture. You see the left is the 3D, and on the right, how it's actually in reality being produced. And also from the inside, the same. You can then very nicely see where the equipment is placed and how much space is left for your lighting in just under the ceiling, for your ducting systems, for your cable ladders, etc., and for your fire and gas systems. And that then translates into reality in the pictures on the right. Another use case, in this case, well, we see that more and more, Today, of course, the electrolyzer power supplies. More and more installations are built to produce green hydrogen, where you have electrolyzers, and these electrolyzers need power, and a power supply can be, as well as the electrolyzer actually, also be placed in containers. And depending on whether it is inside or outside, you can have more like an open container structure that this case is about, or a fully containerized solution for outdoor use. But in this case, they are 4 open container structures of 6.5 meters long, 1.6 wide and 2.4 high. And inside we have a special installation to rectify the power from AC to DC with special rectifiers using diode chopper technology. Here's some overviews of what it then looks like in the design phase with the whole skit, and the end result is then of one of those units looks like this. You see actually a meshed steel protection because it's not for outdoor. This is then has been placed indoor in Finland for the use of production of green hydrogen, which is then further produced, converted into synthetic gas fuel. Another nice example here in the Netherlands, in the Botlek area in Rotterdam. This is a 24 kV substation. This is somewhat smaller. It has the switchgear inside and the other auxiliary equipment. It is on an elevated level, as you can see. We have the stairs. Everything is then comes with the building. And this is one that they wanted to use and relocate quite often, so it's fully relocatable as well. Another very interesting example is in South Korea. This is, of course, in the Busan harbor, the largest harbor of South Korea. And these are 6 charging stations for automated guided vehicles. And these vehicles, they carry the containers that are actually going to or coming from the big ocean ships. And they are electrically driven, and they need recharging, of course. They will then, when they're almost empty, go to one of these stations, and within the station, they will then be connected and be charged. And we delivered 6 of those systems quite recently to South Korea. They are each 12 meters long, 2.5 wide, and 2.9 meters high. And this brings me to the recap of my presentation. I've been trying to bring to you that prefabricated containerized buildings have a real benefit because they not only reduce all overall cost, that's very important, of course, but they can be delivered as a fully tested, integrated product, a real plug-and-play solution. You can use them anywhere you like, in any size you like, depending on your needs and the equipment that needs to be installed inside. There's no disassembly needed for cabling inside the building. Hence, you do not need to retest it outside either. And it is suitable for many energy-related, instrumentation and control-related applications. And I wouldn't be a salesman to also tell you why you would then choose VONK for such a prefabricated building. And there's not only many decades of experience, we built more than hundreds of them already, but we manufacture the buildings and do also the assembly and installation of the equipment in Turkey. And also because of that reason, and because we have done it so many times before, we can actually say that we are the most cost-effective manufacturer, at least in Europe. Also, good to know for you, in the RFQ stage, functional specifications and requirements are sufficiently for us. And when we actually are bringing out a proposal, it will then already contain the basic layout and dimensions of your building. And we do this worldwide. And this brings me to the end of my presentation. I hope you found it useful and that I was able to provide you with some new insights. I'm pleased to answer your questions now. I hope my colleagues register them for you, and let's have a look if you have any questions. Okay, I see a question coming in. How many years can these e-houses endure? I had the table where you can compare the different ones, but it can easily, also depending on the coating you use. But if you use a fully welded solution, you can easily last longer than 50 years. So we see different lifetimes coming by in the RFQs as a requirement, but that's achievable. Yes. It looks like I've been quite clear in my presentation, because at the moment I do not see any other questions coming in. Okay, I see a question coming in from Roxana. Do you have an IP certification for the e-houses? An IP certification, intellectual property, is that what you mean? I know there are certain certifications that you need for, depending on country or application or situation, location. We can fulfill with such certificate, but IP-wise, what we do, we design the building according to your RFQ, and when we deliver the building is yours basically. And often the equipment inside is also free issued, so that is existing technology from big OEMs for the switchgear and for the UPS systems, etc., and for the instrumentation and control systems. I also see a question coming in from Anton. He is asking, what is your execution strategy? Who purchases the switchgears? All right, okay, that is, we are mainly purchasing it ourselves. We have a supply chain of quite a lot of suppliers of different switchgear, and with whom we have already a long-lasting relationship and a long-lasting experience. And like I said before, it is also, we see that also the case that the switchgear or other equipment is free issued to us. We build it in as being actually like, we are a combination then of a system integrator and the designer and builder of such buildings. Okay, yes, I see now that IP might not have been intellectual property, but ingress protection. Yes, that is, of course, there are different ways to protect your building against ingress, and it can also be tested as well. That's what we do. Fully welded is very, very resistant against the ingress. Are there any limitations or considerations for very cold environment? Well, the good thing is about the HVAC systems, they can also heat. We have also examples where you can have a heating system. Yeah, and that is fully controlled. That's, I mean, the condition, the climate control in the building is fully automatically controlled. So very, very cold. Okay, I do not know the exact limits of the absolute minimum temperature, but I would say you could so easily go to a couple of, let's say, 10, 20, 30 below zero, as long as you heat your building inside, of course. Have we provided e-houses in Norway? And no, we have provided them in Scandinavia. By heart, I do not know if it is Norway. I'm looking to my colleague in the room, but not yet specifically in Norway, but why not? We have done it in Finland and other Scandinavian countries, so yes, we can do that. Do we have our own preferred OEMs? No, not particularly references, but like I said, we have quite a good relationship with, well, I would say at least 10 of them. So in different parts of the world. So also depending on where, well, we have our workshops in Turkey, but it can also be that it is built somewhere else. Could be. Then you might want to source it from local OEMs. Let me see. How's the ventilation in transformer containers? A good question. Actually, let's put it this way. We will adapt the ventilation to what is required for the transformer containers. We have done transformer containers before, so it can be. It will have the ventilation that is required. There's different ways to do that. What I also could do, if you have very specific questions,
You can also send them to us, of course. The general email address is info@iivonk.com. So you can always send your questions there. Are there different corrosion protection levels available? Yes, that is then done by the different painting and coating that we use according to ISO 1299 requirements, for example, ranging from offshore to onshore. I know they are often indicated as a C3 or something like a code, depending on the protection level needed or against corrosion. Yeah, and for offshore coating, that is that's also being certified. And the building will be certified, especially for offshore. Because, like you see here, in my background, these 3 containers, they are also offshore already for more than a decade, longer even. But they needed a special certification as well. Is there any limitation for installing HVAC equipment in the roof or modular substations? Oscar Delgadillo is asking that question. Thank you for that question. There's no real limitations. You saw pictures during my presentations where it is actually located at the side of the building. And in the first use case I showed in the Qatar offshore one, it was placed 2 of them on the top of the building. So that you can have different possibilities. The size of the building needs to be efficient, of course, when you are placing it on the roof. Question of Joel: what are the loose equipment that need to be installed inside the EOS during installation? Loose equipment that need to be installed inside the EOS during the installation. When you mean installation at site, the equipment is already in the building. It's all fixed and it's interconnected with cables. What I meant with, I said somewhere in the presentation, you sometimes have to transport loose equipment that will be in a separate container. Can be an open one, can be a closed one, and those are items that need to be installed at the outside of your building, like when you have split type air conditioning, the outside units, for example, or when you have a staircase and railing systems around your building, platforms. These metal constructors are then transported separately and connected to the building on site. Then also a question of Petra. What is the ratio between modules you have supplied in terms of welded wall construction and sandwich panel wall construction? There's no exact ratio available. We do them all. If you have limited weight inside of your equipment, then we can use the sandwich panel buildings, because you can imagine a fully welded building is stronger, and what we often see is that the equipment inside, like switchgear, MV or HV switchgear, they're quite long array of panels, and they may not deflect over the length. So your building needs to be stiff in that direction, but also for lifting, your building needs to have a kind of torque resistance as well. And depending on the weight inside, it actually is determined to go for fully welded or a sandwich panel building. Sandwich panel building is more cost efficient. That is true, but you cannot always use it. What is the largest footprint you have done for a containerized substation? I like the question of Jenka, thank you. And do you have a realistic upper limit? Well, there's no real upper limit, but nevertheless, you would need to have multiple shipping sections that you then reconnect on site. But I believe the one in one piece, I believe that's even, is 30 by 9 by 10 meters. Yeah, that was 30 by 9 by 10 meters. That is quite a large building, I must say. Also multi-story.
Okay, well, I see a question coming in that in our Qatar project, we supplied SIL2 controllers in terms of fire and gas condition protection. Did you also ensure fire and gas dampers were the fire and gas dampers were SIL2 certified? Yes, indeed, sure we did, because the whole circuit needs to comply to the same SIL level. Yes, so we did. And when you have a building which is made from multiple models, that is another question coming in. When you have a building which is made from multiple modules, this is the different shipping sections, do you have some point of attention for the sealing of adjacent modules on site? Yeah, when assembling the buildings, yes. The shipping brakes, the shipping sections, as we call them, they are integrated in the they are called the shipping brakes between the buildings. They are actually integrated already in the design, and it's not added, it's not an added structure, so it's already integrated. And yes, that has, of course, our full attention when you reconnect it at site again, and to make that also water and air tight. I'm looking at my screen and around the room if there are any more questions coming in. There is another question coming in. That is the question I already answered about the SIL2 controllers in terms of fire and gas protection. Okay, I think that most questions have been answered. Again, if you have more answers, I'll be happy to answer them, or together with my colleagues, you can send us an email, info@iivonk.com. I would like to thank you very much for your attention, and I invite you already for our next webinar, which is never far away. So all have a good day and have a good business. Thank you. Bye-bye.